Test, 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 test. Test. Hello everyone, welcome to Lenfi live community session. This is the first time we are doing this, so sorry if anything goes bad, but we will try to improve ourselves. The goal of this streaming is to introduce you to Lenfi V2 and how it works. So in case you are using an app, you should understand the risks and the mechanics that are working behind the protocol. So that's our goal. I'll try to be short in most of the cases, and the content of this video is going to be this way. Firstly, I will introduce into the progress where we are with the audit and the development. Secondly, I will go into the protocol itself, how it is different from the V1 that we already have, and how some certain things are going to work in the protocol. Lastly, we will have questions. So whether you can have a chat, you can use Telegram chat, or maybe there is one on YouTube, and Lucas will help me to capture those questions. Okay. Yeah, so the first thing is the progress, where we are with the audit. We are doing an audit with the Anastasia Labs, and it's already a while when we started it. We had an initial report 2 weeks ago with a very minor bugs we had to fix. We fixed them, and we are going to get the last final report this week. And I believe we can share this report this week with publicly. However, the fixes won't be implemented yet, and there will be some maybe week or two where we implement the fixes, and then it's all done with the protocol itself, with the smart contracts validators, right? Regardless of the audit results, there are design, the V2 design that are going to be in place in any case. And this design is quite different from the V1 that we already have. And that's the design I wanted to talk to you about today. Okay. So I'm going to share a screen, and I'm going to try to explain how things work differently and between the V1 and V2. Okay. On the V1, you know that we had a loan request or or depth requests, where borrower or the lender creates the request. It's this request is more or less, think like if you can see my screen. Yeah, so essentially when someone starts, I will increase this. Essentially, when someone starts the request, they are adding data called datum, details of the loan, and these details can be anything like the token, it can be the expiration date, amounts, and so on and so on. So many data points, and that are saved into validator. Think like this: it's saved into validator into smart contract, right? And from this smart contract, any observer, let's assume it's a lender, they look upon these details and decides whether to give this loan or not. And if they do provide a loan, the date the data is moved from from one validator to another validator, and so it might be so on and so on. And there might be more different paths, but that's what's happening. The thing is, someone creates the request, and the data is moving around. And a very important part of this is that it's peer-to-peer, that we already mentioned too many times. That every person have to find another person who is willing to borrow or to lend, and there is an inefficiencies in the market because it's a double-sided marketplace. You need to find the both parties. The lender have to find the borrower, and borrower have to find the lender. And practically, it's if efficient because it might take a time where you find some right person who are willing to borrow you with the right terms. Okay, so now let's speak about the V2. V2, as you might already know, V2. Huh. Let me try to. Okay, here we go. I will click this. Yeah, so V2. V2 is a pooled lending. The pooled lending is different in many matters. I think the most important is, as I mentioned previously, there is a person who creates some terms, and these terms is a loan request on the V1, and these terms are saved into validator. On the V2, these terms is a pool. This pool says what token can be taken as a loan, what token can be taken as a collateral, what's the Oracle, we will get into this later, what's the Oracle NFTs, and what's the liquidation threshold, or also called the health factor, and so on, and might be other details as well. So these details are saved as a datum into a validator as well, smart contract. And let's call this, for the simplicity, let's call this smart contract a pool. When we have this pool, it is sitting as a smart contract, as an UTXO in some smart contract. Then comes lenders, and lenders, instead of finding the person who is willing to take their loan, or finding the loan they are willing to give, in this case it can be many lenders. I will draw one. They decide to deposit funds into the pool, and in exchange of depositing, they are receiving an LP tokens. They are very important, as in any of the DEXs. These LP tokens proves the ratio, the share of the pool the user have. For example, user received 10 LP tokens for the deposit of 10 Lenfi tokens, and in total there is in total minted 1,000 LP tokens, which means there is 1,000 Lenfi tokens deposited. in the pool. So having a 10 LP tokens or having 1% of the LP tokens, meaning you have a 1% of the total pool. So these LP tokens helps to figure out what's the share of the pool for the lender. And there can be many lenders. They can be many lenders who are depositing to the pool. One thing to mention, there is a concurrency, so-called concurrency issue. Since the pool is only one UTXO, this UTXO has all the funds and it has all the important details. So only one person can interact with the pool at a time. Once the UTXO is spent and a new one is created, the other one can interact with it. This is ugly as it can be, but that's the only way how can we make it decentralized. The thing is, we do have so-called sequencers. These sequencers allows you, instead of making transaction directly with the pool, it allows you to make a transaction into the sequencer to lock funds and data there, and to spend, and someone or yourself even can spend from the sequencer after the pool is available. But yeah, the point is there is a pool created and there are funds funded by lenders into one place. And let's I will draw, for the simplicity, a pool here with a lot of Lenfi tokens. Okay, so we got a pool, we got a funds. The good thing is, let's say there comes a borrower, the guy who wants to borrow Lenfi tokens, and they have some ADA as a collateral, for example. The good thing is they can take the funds directly from the pool. I will call it loan, and a pool will allow. So before all the verification process have to be put on the lender, on the V1. On the V1, lender had to decide, okay, what's the collateral I want to use for this specific case, and the amount and the tokens and the loan. What's the interest rate I do accept, and so on and so on. In our case, in the V2 case, the interest rates are calculated by the pool. You can always know the formula which involves the currently active funds and currently available funds, or in simple terms, utilization rate and what's the remaining funds. So interest rate is calculated by the pool. There is no power by the depositors to decide what interest rate should pool give. When they are depositing funds to the pool, they assume they must agree with the pool terms, with the pool calculations, which are public. Okay. So interest rate. Important thing is a collateral. When someone created a pool, they have explicitly defined what's the collateral can be used for this pool. Okay, so this collateral can only be used in this borrow case. Collateral. Other thing is the oracles, but I won't go too deep into it. So what's happening? The borrower is taking a loan, let's say 100 Lenfi tokens, and in order to do that, they have to deposit a collateral. Collateral is deposited to another smart contract. Smart contract called collateral. That's easy. Also, they maintain an NFT, which is not that important right now. But the point is, they get a loan by depositing 1,000 ADA as collateral. So in this case, borrower has the loan, and they after some time they decide there are two ways. One way is to repay. Other path is to get liquidated. Let's assume the borrower is going to repay the loan, and what's happening when they want to repay the loan because they have put more collateral than the loan value, and when they want to repay the loan, they're going to spend the collateral. Let's say this transaction. They want to spend collateral from the collateral smart contract, And in order to do that, there is a validation happening saying, okay, you can repay it only if you burn borrower NFT. And if you repay loan to pool, loan plus interest to pool, which is important. And so there must be an output going back to the same pool, which is 100 Lenfi plus 2 Lenfi tokens. Okay, and that's how it more or less is happening. And if it's done, if these two are available, it means okay, borrower can spend from this contract, which means they can take back the collateral they have saved a long time ago. The important thing is for you to understand that right now in this example, there wasn't only one validator, not only one smart contract, but two. There was one called pool, there was second called collateral, and these two smart contracts are validating different data points, different transaction parameters to make sure the protocol as a whole is working correctly, which means to make sure the interest is paid. It's not. It is checked in the collateral smart contract, and it checks whether the pool is getting loan paid back and so on and so on. So this validator involves checking what is happening to this validator, which might be not that important in this case. Okay. I will not go into liquidations. Liquidations is different from the repayment because anyone can liquidate a loan, which means if the loan is under collateralized, if the data saved in this UTXO presents that, okay, someone took the loan more than the loan value is decreased enormously in regards to the collateral, then it is under collateralized. So they can liquidate if it's under collateralized. If it's yeah, that's basically the only criteria to get a liquidation. So anyone can liquidate a loan, and when liquidating they have to repay to the pool. So repayment have to happen the same way it happened in this just borrower repayment. So the liquidator have to make the same output to the pool with the same loan plus interest value sent to the pool. Additionally, when a liquidator is liquidating, they can receive some of collateral. That's the liquidation fee. That's the reason why liquidators will liquidate the loans, because they will actually gain the value. One thing to understand is when a liquidator is liquidating the loan, in this example, they receive ADA while they send Lenfi, because that's the loan token and that's the collateral. They receive the collateral while they send the loan. Okay, and this is the important. This is how we can go into oracles. Okay, that's why we need oracles, because oracles are the ones who are saying how much of collateral this one needs to pay, how much of collateral they are going to receive, and how much of the loan they have to send. And that's where oracles comes into the play. So oracles, there are on the DeFi, on whether it's a Ethereum ecosystem or whether it's a Cardano, everyone is having their own oracles journey. Okay, Lucas left me a comment. Let's see if I can make it more. Yep. oracles. Okay, so every DeFi app having a different oracles experience, whether it's a Aave, whether it's a Compound or anything. So we have our different experience as well, and I will try to explain it how we are doing with the oracles. So first thing, oracle is nothing more but data, data saved in the smart contract. It's a different smart contract. So this data represents for us a couple of parameters. One is very important, is a token A, then there is a token B, then there is a token A amount and token B amount. And for example, it could be, again, Lenfi, then there is ADA or Lovelaces. Then it says, okay, there is this 100,000 of Lenfi, and there is a, to make Lenfi more expensive, 1 million of ADA. So this data is a pool data. If you would go to MinSwap, you would actually see, okay, there is a pool on MinSwap DEX. Let me try to change the color as well. There is a pool on the MinSwap DEX, and this DEX have this amount of Lenfi tokens and this amount of ADA tokens. And based on that, let's assume the spot price of the Lenfi token is 1 million divided by 100,000, which is 10 ADA per Lenfi token. That's how you see the price when you go into Taptools, MinSwap, or CoinMarketCap or anything. That's how you define the price of the token. So someone would ask, okay, why you don't simply have 10 ADA in this place? Why you are getting all the pool details? Like what's the token A, token B? The thing is, because on Cardano right now there is not that many liquid pools on the DEXs, and if we would be taking this spot price of 10 ADA, we would assume someone depositing a collateral of let's say 1 million Lenfi tokens. They are depositing 10 million ADA as a collateral. Well, actually, if someone would try to swap this amount of 10 million Lenfi tokens, they cannot receive more than 10 million ADA, and likely they would receive something like, let's say, 6 million ADA or so. So we are taking account of this. Protocol is taking into account the liquidity available on the DEXs. Okay, so that's what we use. Another thing is, so that's basically the data of the oracles, and that's the data that is needed to decide in the liquidation or whether a borrowing how much of the tokens one should be sent to one contract or another contract. Okay, so how we get this price? There are multiple ways how can it be done. One is very, let's say, centralized. Okay, so I will try to centralized is simply to do it ourselves. We could simply, I don't know if you are using our UI, or whether we could do some sort of the signing data or signing a transactions or something. And we would decide, okay, this loan can happen, this liquidation can happen because they are performing in the good behavior. But we would need to validate it. Like we would be the parties that we would put very important signature at the end of every transaction, and that's one way. Another way is let's use available Oracle solutions, right? There is Orcax, there is Seek3, maybe there is someone else, and maybe they have something similar what is needed, or even even more, they can do what we do need, right? They could simply store the data that is needed, update it reasonably and timely, how we do need, and so on and so on. But the problem with that is, at the current state, we are not sure. First, we are not sure how often we do need data, how often data is needed. If we go with let's say with the ORCAX, they would say, it would be something like this. We would have to agree on the data data expiration dates, like data expiration, how long the data is active, how long data should be considered active. And in regards of this, their Oracle solution would be creating a new UTXO with the data. And they would just spend the old one and create a new UTXO and so on and so on and so on. So it kind of works, but it might end up that in the way when, let's say, there were created multiple new UTXOs, and well, actually, someone borrowing from this pool and requesting this data only happened in this case. Only only consumed this UTXO, and every other time it wasn't needed, but it was paid, and it was paid for this and for this and for this. So this money would be wasted. This ADA would be wasted for the transaction fees and maybe other fees, while only one disk would be the one we needed. Okay, the easiness on the Ethereum ecosystem is that Chainlink oracles, they are providing data on their needs. So basically, you should imagine it. You could get the data when you need it. So no one is updating the oracle's data like here and here. They are only doing it here. They are taking just the data and consumes it when it's needed, and doesn't have to pay every other time when they don't need it. So that's the ugly part. What right now we do have, and we don't want to pay for the times when data is not actually needed. So our solution. So that's why we are going to, I would say, experiment with a different solution. And this solution looks like this. First, the same data that I did. The same data is called Oracle for the simplicity. Okay, and it also have an NFT, so we know it's unique. So this data is an Oracle in our protocol case, and this data have very important two features. One feature is expiration time. Other feature is maturity time. Okay, this it also have the previous things I haven't mentioned, like the tokens and amounts, and these two comes from the dexes. Okay, so this whole data sits in the validator called collateral. Okay, and a very important thing is this smart contract validator called, not the collateral, sorry, Oracle, called Oracle. It allows to update these two parameters and these two only in the way that is programmatically described, which means it can update the token amounts only as it currently is on the DEX. It can be any DEX, but for the simplicity, let's see the MinSwap DEX. It have the same parameters as amounts. It has an NFT, yeah, on that saved UTXO. On the validators, it has those two. So only these two can be saved into our Oracle. Okay, and when it's done, when this data is copied, when the tokens amounts are saved into Oracle UTXO, they update two values: the expiration time and expiration time is more or less like now plus let's say 30 minutes. Okay, which means this data is available from this update for 30 minutes more. And other very important thing is, instead of taking the actual amount that is living on the DEX, it must be an average of the current value in the Oracle and current value in the DEX. So for example, if for simplicity I will simply say price, the Lenfi price was 10 ADA on the Oracle, and on the DEX it currently is 12 ADA. The new value created on the Oracle UTXO on our protocol is going to be 11 ADA, just an average of both. In that way, if there is something very drastic in the market, let's say someone dumps a lot of tokens in one of the DEXs, there are this sudden decreases are averaged out, so the liquidations doesn't happen where we don't want them to happen. However, it's not a best solution, but that's the most solution we think is the most decentralized. So the averaging out the price is a very important thing. We are averaging things, okay? That's what we the auditors have asked us a couple of times, and they have pointed to this issue a couple times, saying, okay, your oracles on the times where Cardano blockchain is very congested, and let's say, or even DEX UTXOs are very congested, you might end up where users cannot use the data because it's expired, or they might be using incorrect data when the prices are moving very fast. Like it wasn't, let's say, if it was a 20 ADA, the average would be 15, even though it could be a very short span of the time. So this is very, very important thing to mention. The oracles are averaging the price, and it is taking data from the DEXs. Okay. How we are trying to combat these issues is that I mentioned here that on the oracles we also add a maturity date. And it means smart contract doesn't allow to update oracles more often than let's say every 10 minutes. In this way, if someone could attack our protocol on the way, if the token price drops enormously, and someone could simply update the oracles twice or 3 times or 4 or 5 times, and they would be able to capture this dip of the token while the market makers or simply the market wouldn't bounce back to the normal levels. So that's why we added a maturity date, and this maturity date assures let's try to make it more. Zoom in. I will make it more visible to you guys. Okay. So maturity date. Having this maturity prevents some of the attack vectors that could happen on the protocol. So that's it about the oracles. And just to recap it all and summarize, one thing is data is taken from the DEXs. For example, MinSwap. If you look into MinSwap, what's the price of the token in the MinSwap right now? We save this as our data on the oracles. Other thing is it's averaged. So it's averaging out every time oracle is updated. Another thing is it is taking a pool liquidity into an account. So some project owner with a lot of tokens, like millions of tokens that don't even have the value as they supposed to have on the spot market value, They can't take too risky loans, or they can't leave too risky collaterals, assuming and not like to extend the value over than it is. Other thing is oracles have the expiration and maturity dates. Oracles. Yeah, so that's it. One thing I haven't mentioned yet is that anyone can update an oracle. There is no reason to give any of the permits updating the oracle because smart contracts already defines how it can be updated, and it can be updated on the matter on the way I already mentioned before. So anyone can do this. Okay, so let's go back to the loan. Here the guy have taken out the loan and repay the loan, and after repaying, so before they repaying, there was a pool. Pool had, let's say, 1,000 Lenfi, and after repaying the loan, pool has 1,002 Lenfi tokens. Which means the person who have deposited funds at the very beginning here deposited funds into the pool and received 10 LP tokens for 10 Lenfi. Right now, when the pool have more Lenfi tokens, but the LP token is the same 1,000, the same person can create the transaction where they are withdrawing the funds from the pool, and they are withdrawing the same 1% of the funds, which is not anymore the 10 Lenfi, but it is 10.02 Lenfi tokens. So that's how they collected an interests on the value. Other thing is they don't, if they decide not to withdraw the all the LP tokens that they do have, not the 10 LP tokens but the 5 LP tokens, it will simply be divided by 2, or 1 LP token, so it's going to be divided by 10. So they don't have to withdraw the whole amount, but they can withdraw whatever amount. Yeah, they can withdraw whatever amount they want. Okay, another thing is, I think Yannick was asking us is, okay, so what happens when there are no funds on the pool? Okay, so there is that 1,000 LP, 1,000 Lenfi tokens, 1,002 Lenfi tokens, and 800 is borrowed out, and the pool still only has 202 LP tokens, and some very huge lender is having 300 LP tokens, and they can't withdraw all the funds. So that's another thing everyone who is depositing to pool have to consider is, if there are no funds in the pool, you can't withdraw them. Like you can't withdraw the funds that are not existent, which means this person could withdraw 200 LP tokens because that's what they currently have on the pool, and they would simply burn, in this case, 200 LP tokens and receive in exchange some amount of the Lenfi tokens, and they still would have 100 LP tokens that can be withdrawn any other time. So these guys would have to wait when someone repays the loan, or someone else deposits the funds into the pool in order to claim back the remaining liquidity. To fight this risk, there is a, as I mentioned previously, pool is calculating interest rates based on utilization rate, which means if there are 200 if there are 200 if there are 800 out of 1000 borrowed, which means utilization rate is 80%, interest rates are rising extremely higher. And it is saying, okay, if someone is depositing the funds, if someone is borrowing the funds from this pool, they are going to pay up APR of, let's say, I can't come up with the numbers, let's say 100% or more, or whatever the rates are, which involves adding more funds into the pool. So people seeing high up APRs are going to deposit to the pool. Therefore, there's someone who, if there are anyone who wants to draw the funds, they can do it now. Otherwise, they simply can keep the funds there because it's already yielding a higher interest rate. Another thing is, which works differently on a different protocols, is when someone takes the loan, they have fixed interest rates, which means if you took out the loan and it is saying that you are going to pay 10% annually, this 10% is going to stick you for as long as you repay or as long as you get liquidated. So the loan has fixed interest rates. That's a very important thing to mention too. Okay, so there is a plan that I try to talk through today, and so I'm going to leave. So there are some other risks. One very important risk that I mentioned is the oracles. It is averaging price. It is taking the current DEX prices. So whether the DEX can be congested or whether the price can be down for some reasons in effect can be down a lot. It can affect the way how the loans are made or how the liquidations happens. So you guys must know when you are using a pool, the protocol. Other thing is the pool congestion, which means since pool is open and anyone can use the pool, there is only one UTXO that can be spent directly with a pool. So if there are two people trying to interact with a pool on the same block, only one is going to succeed. Another one is going to fail, and a new pool state is going to be created. And on this new state, the same guy can now interact with the same pool, slightly with a different data at the time, but they can interact then. So not everyone can interact with the pool at the time. Therefore, we have also for the very basic user, so we don't get a problems using our platform. We do have an orders or batchers. I won't go too deep into them, but if this happens where two people try to interact with a pool and someone creates a transaction and submits into the mempool, we automatically direct the second one to the orders, to the batcher. And we explicitly say, okay, your transaction is going to be submitted with a batcher. Therefore, you're going to pay some batcher fee. But it's optional. You could say, okay, I'm going to cancel this one and wait another block and try to interact directly with the pool because it's cheaper. It's up to you. But simply to have a better user experience, we are automatically directing failed orders into full transactions into orders. Okay, so what I'm leading here is that pool might be busy when multiple actors are interacting with it. And the bad thing is in here, someone bad actor, someone bad can they can keep the pool busy as long as they can by simply depositing small funds or borrowing small amounts or withdrawing small amounts or so on and so on. But simply they would they would be doing the same for every pool transaction, every block. It's going to cost them. There are going to be money needed to be paid for them simply to interact with the pool and transaction fees, blockchain transaction fees, but they can do it. So basically, they can attack our our protocol by making small loan amounts. So that's the risk, and that's the risk we have to fight. We have to have a prevention mechanisms available. So the mechanisms are there are, there are the main mechanism to prevent it is a pool fee, pool interaction fee. Uh, this pool fee is some sort of the fixed value. Let's say 1 token, because it's calculated into tokens. 1 token for the pool. Let's say and for the Lenfi ADA pool, that is like it has a unique ID. For this exactly pool, someone is behaving on the way that we don't want. Like they are making small transactions, and we see that average users, they can't perform their normal transactions that they do want. We do have the power to add the fee to the interactions, which means if someone is making the transaction after the fee is implemented, they would have to pay 1 token to the pool every time they interact with it. And everyone would have to do it. Whether you're a good actor, whether you're a bad actor, you will need to pay this fee into the pool every time you're interacting with the pool. We take it as a safety measure simply to push the bad actors are going to the bad actor would need to spend more money in order to keep the pool busy and not to allow the users to interact with the pool. So the fee, very important thing is how the fee is managed, because I said fee is okay. So the fee is currently the fee is going to be managed by the team. So someone would need to look into activities on the pool and seeing that the pool someone is misbehaving with the pools. We would update some update pool params NFT. I don't want to be too complex, but there is a special NFT created when the pool was created. And this NFT is saying, okay, this is the fee for the protocol to use. This is the fee for the interaction fee. And there is a liquidation threshold and maybe some other data. So updating this thing, it has to be some centralized party responsible for it. And we are taking this, I would say, the risk of managing it because there is not really the good way how we can solve it on the decentralized way. So there would be 2 ways. One is act quick, and other one is have the slow actions. The quick one is a centralized, like the BNB chain, while the slow one is decentralized. Let's say it's a more like some other decentralized, like Cardano chain. Other one is the centralized way. For this, for this case, we chose a centralized way because it's not very impactful to the whole of the protocol. It's simply a control of the fees. This fee have a hard cap, so it can be more than, let's say, 10 tokens. So we as a team would say, okay, fuck everyone, we are going to make a very huge fee so no one can do anything with the protocol anymore. That's impossible because there is a hard cap programmed into the pool validator, so it can be more than this. However, this value can be managed by the team. The good thing is this value is managed by updating data on UTXO with some sort of the params NFT. And right now it's going to be saved into validator, but it can be added to the validator. Can be any validator, so it can be so it can be any validator, and it can change anytime after pool is created. So right now maybe it could be a team who is controlling it. After that, we could move this NFT to some validator of the oracles or something like some anything that we don't know. So it can be adjusted anyhow. Okay, I will try to be quicker. I tried to make it to 1 hour, but it looks like it's already there. So other issue is a batchers. No, it's not an issue. I have to mention we are using a batchers. Batchers are going to be open, which means anyone can spend from the batcher as long as they are completing the requirements required by the order creator. For example, I create a batch order saying I want to get a loan of 100 Lenfi tokens while leaving collateral of 1000 Lenfi tokens. If these are criteria I'm going to receive, okay, then anyone can spend from the pool and send me the tokens I have requested. There is no slippage. You have to understand there is no slippage. You have to have exactly the terms that you want to receive. And it's very likely if you say, okay, I will leave, I want to receive less of the, for example, you are deposited liquidity into the pool, and you want to claim some of the liquidity. You would know that, okay, I could get for the 50 LP tokens, I could get 50 Lenfi tokens, but I ask only for 49 Lenfi tokens. While you should receive 50 because of the pool calculation. It's very likely you're going to receive 49 because one Lenfi token might be kept by the batcher executor, by the person who is executing the batching order. They will extract as much value as they can from every transaction. That's why we cannot use slippage, and that's why it is open source, which means anyone can use it. And having it this way means it's more decentralized. We would not need to control the batchers. We would not need to do some of the governance votings or anything simply to say who is bad or good behaving on our protocol. Anyone can use it. It's a free market. The trade-offs are that there is no slippage. So, which means if your order wasn't executed at the time and token price have increased or there is not that much of the LP tokens as you were doing at some point, you will have to cancel your batching order and create a new one. With a new pool state, hopefully it's going to be directly spent from the pool. If not, you have to create a new order. Okay, so I won't go deeper into pool manager NFTs sadly today. I think we could do this on the other video, maybe in the next week or maybe sometime, anytime other. So we have a content to share. But the pool manager NFTs are NFTs held by the pool creator, and they have the power to delegate the pool because just getting back to the screen. When pool was created, there are two smart contracts. One is the pool, other one is collateral. Okay. The pool, it's deposits. So if the pool was Lenfi tokens, so deposits are Lenfi tokens. But the collateral token, collateral smart contract is a collateral assets that could be used for the loans. And it can be, for example, if it was ADA, there might be some ADA used for the loans in the pool, right? So this ADA can be delegated to the SPOs. So and it can generate some extra yields. So the pool manager NFT allows to delegate a stake address related to these two smart contracts. Every pool have a different address. Every pool have a different uh, pool and collateral validators. So when pool manager NFT is managing some software, the pool, it's only the pool that is related to these two, because these two have the same stake address, and these two can be controlled by pool manager NFT. They can even create a stake pool if they want. But the point is, they can delegate however they like. However, so if they delegate to any SPO and there are some results collected, has some yields made from the staking, from the delegation. For example, there is 100 ADA that can be withdrawn from the stake address. These 100 ADA can only be going into the pool. No one can take these funds. No one can do whatever they like with the funds. The only thing is they can only go into the pool. It is very important because it's not sent to the borrowers. It's not sent to the whoever. It can only go to the pool. And since the pool was Lenfi, while the earns the interest was on ADA, they have to swap the tokens. There must be an ADA to Lenfi swap. And again, oracles must be used for this transaction. And let's say it was 10 Lenfi. So they're going to deposit 10 Lenfi, and anyone can do it. Very important. Anyone, once again, because it's centralized, anyone can do it. The thing is, we assure the pool depositors will want to do it, because if the pool is, let's assume 20, it's not going to happen, but it's 20 Lenfi tokens, and at a time you have a 10 LP tokens, which means you have a 50% of the pool. With that 10 LP tokens, you can take 10 ADA, so half of 20, or you can take 20 plus 10, so it's going to be 15 Lenfi tokens. If you simply withdraw the funds from the pool, delegation, rewards from the delegation, into the pool, then the pool is going to be larger and you're going to receive more funds with the same amount of LP tokens. That's your motivation to make the withdrawals into the pool. Okay. And no one is getting paid for the withdrawing, which means there is no fees to benefit you. There is no some sort of the paid actor who should be doing this action. So it's the free because you, a depositor, would likely do it on the UI or however in order to get more funds. That's your goal. Yes, so that's about the delegation and the pool manager NFT. Sadly, I haven't touched it more, but let's do it in the next time. So I will look into the questions that we do have. Not so many of them, luckily. So about the concurrency, could you not shard the single UTXO into multiple UTXOs? For example, 500 ADA each, and then have borrowers make their borrow request in 500 ADA increments. You can. If you want to take a loan of 1,000 ADA, 1,000 Lenfi tokens, you can create a multiple loans from the same pool with the same collateral, slightly different interest rates and slightly different interest rates, but you can do this. Additionally, you don't have to borrow from the same pool. If you want to borrow Lenfi tokens, and there might be multiple pools with the different collaterals and the same collaterals as well. It can be Lenfi and ADA. It can be the same Lenfi and min tokens and anything and anything. And what you carry is, and let's assume you have all these tokens and all you want is a Lenfi, you can create a single transaction that is borrowing multiple amounts like the Dex Hunter, which is so popular right now, from a different pools on the same transaction. And you would receive in after all of this, you would receive if it's a free pool interactions, free loans, you would receive free NFTs, borrower NFTs, and you would have to save free different collaterals for these loans. But it's totally possible in one transaction, and that's we've been fighting for this very hard, simply to have to on the V1 there is explicitly defined on the validators saying only one smart contract can participate in this transaction. Which means if there is someone trying on the same transaction make the two loans is going the smart contracts are not going allow it to happen. So only one smart contract could happen transaction. Smart contract spend redeemer can actually happen on the V1. And it's more or less how the most of the Cardano chain smart contracts are added, because it's more safe programmed, because it's more safe. On the V2, we don't have this rule. We allow to have as much smart contract interactions in one transaction as you do like, because it's more advanced. I can allow it to, and Mika helped to get it there. So thanks to Mika. The premise of it is it would allow people to create the transactions that would make multiple different things in one place. Right now, you can only swap, or you can only buy NFT, or you can only make one loan in one transaction. We want to be on the place where you could actually make the loans, make the swap, and borrow borrow an NFT from Fluid tokens on the same transaction. So that's what we are building for. We want to be integrated with the other possible actions, because this is where people can be more creative. Hopefully they will be, and that's the right thing to do. So yeah, so if you want to make a big loan, you can borrow from multiple pools on the same transaction. It's all fine. Yes, so that was the second question, and I answered. The other one is, are there any plans to enhance the experience of buying Serum Lenfi bonds directly from the V2 platform, or going to remain in direct way JPEG store? Definitely, we are not going to do it right now. Of the V1, how the NFTs volume on the V1 on the JPEG store is not that huge, so there is no really a reason for us to build something separate right now, at least, unless things are going to change, because we try to follow the users, not try to build the things and then assume someone will use it. Okay, we tested with the JPEG store, it didn't get much of the volume, it didn't get much of the interest, so that's fine. You can complete the function on the JPEG store for now. Okay, that's it. Okay, so probably everyone is asking, what's the anticipated V2 launch date? I don't know. Honestly, I do not know. As I mentioned, this week, audit is going to we are going to receive final audit version. After receiving the version, this is how we see it. It might be different, but this is how we see it. After receiving the final audit version, we are going to implement the changes. Let's say it's a 1 week or 1 week and a half, and we already have the infrastructure ready for the mainnet. So the pre-prod network or the mainnet, they are very, very similar, and we have the infrastructure ready. So we just need to change some of the API keys and some of the URLs, and voila, we are on the mainnet. So there's not that much left from the development side, only the completing an audit and fixing the found bugs. Definitely there are going to be some, it always is. And then we are going to do some of the marketing and go for the mainnet. That's the goal. I would say month. I can't say any months, any weeks, but that's what I know. Uh, this week final audit, 2 weeks to fix stuff, and maybe sometime then we are going to have a mainnet. Yeah, that's it. Sadly, I couldn't speak about Apple Manager and NFTs more because it's pretty cool. But if you guys want, we can have another video sometime short, sometime soon. The goal, I will summarize why we are doing this. The thing is, you, the guy who is going to use our platform, who are going to trust the UI, the validators, the smart contracts, the pools, oracles, something, you are taking the responsibility that you do know how the things works. I'm pretty sure it's very minor public who actually looks into the code, into validators, into smart contracts, and says, okay, that's cool, that's what I can use. So our goal with this video is try to explain what are the risks of the protocol, so you should watch out, and what are the bad things that could happen. And there are some unknowns. We don't know how things will work, but we try to give you as much information as possible so you can take this responsibility. That's the goal. Yeah, that's it. Sorry for the handwriting. I saw the comments on Telegram that I'm like a doctor. It's not easy to write with a hand. We have keyboards in these days. Hopefully you enjoyed. Thank you and bye bye.